Hello friends, I am Rashmi. Welcome to SRS Info. Today we will continue with the chapter Common Inorganic Pharmaceutical Compounds. This is part 2. In the last class we discussed about the Arrhenius concept of acid and bases. Today we will continue with Bronsted-Lowry concept. Let's understand in detail about this concept. Bronsted-Lowry concept. This was described by J.N. Bronsted and J.M. Lowry in 1923. That's why this concept is known as Bronsted-Lowry concept. This concept is also known as protonic concept. This is completely based on the acceptance and rejections of ions or protons. That's why it is known as protonic concept of acid-base character. We can define this concept as acid is any substance that can donate a proton to any other substance, and a base is any substance that can accept a proton from any other substance. And this substance may be molecule or ion. This is the definition of Bronsted-Lowry concept. Let me explain in detail. In simple language, we can say that acid is a proton donor. That means acid has a proton to give to a base or any other substance. And base is a proton acceptor. That means base is ready to accept the proton which is lost by acid. Okay, when an acid loses its proton, it becomes base, and this base is known as conjugate base. This base is known as conjugate base. In another word, when a conjugate base is added with a proton, it again becomes an acid. Clear? So this is the interchange or the acceptance and rejection of protons. This is the game of this concept. Conjugate of an acid is the substance formed by the loss of a proton. This is the acid. When a proton loses from this become a conjugate base. Okay, this is the proton separate from this acid, and this area, this species becomes the conjugate base. And when a proton added with this conjugate base, it again become acid. So this is the pair. In the case of carbonic acid, again this example, this proton is removed from here or losses from here, this become the conjugate base. The base formed by the losses of a proton from an acid is known as conjugate base. That is written here. Conjugate of an acid is a substance formed by the loss of proton. In another word, we can say that according to this Bronsted-Lowry concept, acid ionizes to a proton and form a conjugate base of an acid. Okay, acid ionizes to a proton and forms the conjugate base of an acid. This is the concept. And the same criteria is applicable to base also. In the definition, we explained that the substance may be either an ion or a molecule. Okay, so Bronsted base is a neutral molecule or anion which ready to accept this proton which is removed or lost by the acid. Okay, the species formed when a proton is added to a base is known as the conjugate acid of that base, which I have already explained to you. This is the base. When this base is added with the proton, it becomes the conjugate acid. Acid loses its proton, it becomes a base. This is known as the conjugate base. Okay, base accept a proton, this became an acid, and this acid is known as conjugate acid. This is the pairing. In the case of ammonia added with a proton, it becomes acid. This is the conjugate acid. Okay, water also has this property. In this case, this is not a molecule, this is the ion which has a basic property. Okay, and the ion with this basic property added with a proton, it becomes water, and this water molecule has acidic quality, and this happens only in the presence of strong base. Okay, and this concept also explained about some exceptional species. Some species, certain exceptional species, may react either as an acid or as a base, and water is such a molecule. And this quality depends on the relative chemical conditions which take place. Okay, it is the relative chemical conditions that determine which type of reaction will take place, either acidic or basic. Water in the presence of strong base act as a proton donor. That means water in the presence of a strong base act as a proton donor. Proton donor means acid is a proton donor. In this case, water act as an acid. And again, in the presence of strong acid, water is ready to accept a proton, and in this case water acts as a base. This is the dual characteristics of water, that based on the relative conditions it acts as either acid or as a base. Bronsted-Lowry concept again explained about the reactions, about the conditions. Bronsted-Lowry concept again explained that an acid cannot exhibit its acidic property unless there is some substance to accept the proton. That means an acid can exhibit its acidic property only in the presence of a base. The presence of base is necessary to exhibit the property of an acid. Okay, this is what this concept explains. An acid cannot exhibit its acidic property, that means proton donation, unless there is some substance to accept the proton released by it. If there is no substance to accept the proton released by the acid, it cannot exhibit its property. Now, this is a pairing: acid, base, acid, base. Conjugate acid base pair, conjugate acid base pair. In the case of water, water shows both the quality. Here, this is acid, okay? And water acts as a base here. How? This hydrochloric acid, this ion. This is the acid and this is the base. Acid base pair. Again, water acts as a base and this is the acidic property. This ion has acidic property. So this is the conjugate acid pair, acid base pair. In this case, in the presence of hydrochloric acid is a strong acid. In such cases, water acts as a base. But look here. Here, this is the acid column. Water acts as an acid because this is a strong base. In the presence of strong base, water acts as an acid and it forms the conjugate base with OH ion. And this ion form conjugate acid base pair with this. Okay. And this illustrates the acidic and basic nature of water, and this property is known as amphoteric nature of water. Based on the conditions, based on the chemical conditions, water acts both as an acid and base. And this property of water is known as amphoteric nature. We have some other examples also which shows this amphoteric nature, like liquid ammonia, glacial acetic acid, formic acid, concentrated sulfuric acid. All these are known as amphoteric solvents. Okay. This concept explained in detail about the qualities of this, characteristics of the strong acid, base, etc. That means strongest acids have the weakest conjugate base. We explained in the case of water also. The strongest base have the weakest acid, weakest conjugate acid. Strong acid lost their proton because they are not attracted very strongly. Okay, because strong acid loses their proton because there is no possibility of acceptance for attraction. Okay, in such cases, strong acid lost their proton, so that it is not to be expected that the proton would come back. So that this chloride ion, NO3 minus ion, SO4 ion, all these are weak bases. Because chloride ion, this is formed from the strong acid, hydrochloric acid. Okay, and in such cases, it loses the proton, that they are not attracted very strongly. In the same way, the conjugate base of a weak acid would be a strong base. Weak acid would have a strong base. Hydrochloric acid, sulfuric acid, etc. are strong acids, and their conjugate bases are so weak that there is no possibility of reverse reaction. That is why these acids are strong and their conjugate base are so weak. This is the concept of acid and bases, which is explained by Mr. Bronsted and Lowry. Okay, I hope you understood about this concept. In the next class, we will discuss about Lewis acid-base concept. Hope you enjoyed this video. Thank you.